We've heard about terraforming the Moon and Mars as we attempt to colonize space. But what about Venus? If we did manage to terraform our neighbor, one day it could look like this. Could we live here one day? How different would it be from life on Earth? This is What If, and here's what would happen if we terraformed Venus. Believe it or not, Earth and Venus are very similar. At times, Venus is even referred to as Earth's sister planet. They're both roughly the same diameter, have the same mass, same gravity, and are both made out of the same material, a central iron core and a rocky mantle. Unfortunately, the comparisons end there. Unlike Earth, Venus is extremely hot, has an incredibly dense atmosphere, and toxic fumes on its surface. What would we need to do to make it habitable? Scientists and astronomers have been theorizing how to terraform Venus for over half a century. The two biggest issues that need to be solved are the atmosphere and the temperature on Venus. Currently, the surface of Venus is a sweltering 462 degrees, hot enough to melt lead. And the atmosphere, made up mostly of carbon dioxide, is 93 times as heavy as Earth's. One proposed way of altering Venus's atmosphere is to bomb it with hydrogen. Hydrogen bombs, when reacting with the carbon dioxide in the atmosphere, would create graphite and water. This would fall down to the planet's surface and cover 80% of it with oceans. Mind you, they wouldn't be nearly as deep as Earth's oceans. Venus would only have 10% the amount of water that Earth has. This would take a lot of hydrogen. The only way we could get enough is if we were to harvest the resource from Jupiter or Saturn. This approach would also require iron aerosol, a material that can be mined from asteroids. If all went according to plan, the dense carbon dioxide atmosphere would be reduced to being just 3 times as heavy as Earth's. Okay, that's manageable. This would also help clear the clouds of sulfuric acid that hang over the planet. Okay, the atmosphere's clear. Now, what about the temperature? One way to cool the surface is with solar shades, a series of small spaceships or one large lens that would divert the rays of the sun. These solar shades could be placed on the surface of the planet or in the atmosphere, slowly working to cool down the planet and reduce radiation, another issue that would need to be resolved before we started living on Venus. In addition to solar shades, NASA thinks that we could build floating cities above the clouds of Venus. These would work as a safe living space as we learn and attempt to terraform the environment. To cool the planet even more and to speed up the process, cooling pipes could be put on the surface of the planet. These pipes would take heat from the surface and bring it up to colder parts of the atmosphere. Now we have a suitable atmosphere, a proper temperature, and clean air. But there's one other huge issue that humans might have if they move to Venus. They'd have extremely long days and nights, since Venus rotates once every 243 Earth days, meaning a day on Venus is 5,800 hours long. Not to mention, it's the only planet in our solar system to rotate clockwise, meaning that its extremely slow sunrise would happen in the west, and sunsets would be in the east. We could create the illusion of a 24-hour day cycle by using massive mirrors and having them rotate to reflect the sun. If this managed to work correctly, Venus would feel just like home, with maybe a touch less gravity. After all this, Venus would finally be habitable. Sure, the planet would rotate differently and you'd get a different view of the sun, but it could be another place for humans to live. Scientists theorize that it could be a backup planet one day. Studying more about Venus could teach us something about Earth. Venus suffers incredibly strong greenhouse effects, the cause of its extreme temperatures and dense atmosphere. By learning more about cooling this planet, it may unlock the secrets to cooling our own and maybe make our home last even longer.
Welcome to hell! Sorry, I meant Venus. Welcome to Venus. Some say it's Earth's twin, but this world is nothing like home. And you're about to experience this scorching hot landscape firsthand. Your mission is to spend 5 seconds on this hellish planet. And trust me, these are going to be a very long 5 seconds. Venus is the second planet from the Sun and our nearest neighbor. At its closest approach, Venus is a mere 40 million kilometers away from us. After just 4 months in space, you'd finally be able to witness this beautiful but deadly planet up close. 4.5 billion years ago, Venus and Earth formed in the same corner of our solar system. This space rock is about the same size as Earth, and its gravity is similar too, but unlike our home, the surface situation on Venus is extreme. We know this because we've sent probes to this scorching world. Some probes orbited it, some made a flyby, and some even landed on the surface of Venus, but those didn't last very long. What happened to them? Well, that's what you're about to find out. Time to make your way down to the surface. Don't these clouds look beautiful? Well, don't inhale them. These yellowish bands streaking across the sky are clouds of sulfuric acid. If you could only get a whiff of them, you'd smell the reek of rotten eggs. But to do that, you'd need to remove your helmet, and I definitely do not recommend that. At a height of 50 kilometers above the surface, visibility is poor. You'd hardly be able to see anything. The incredibly thick atmosphere would block views of this planet and its tens of thousands of volcanoes. The atmosphere is mostly made up of carbon dioxide, and because it's so thick, it traps heat on the planet's surface, keeping it nice and toasty. Just how toasty are we talking? You're gonna find out the hard way. As you descend another 15 kilometers, the haze would begin to clear. The world below would finally reveal itself. A rust-colored surface covered in mountains and volcanoes. Looks like this volcano is still active. You'd fly around a little to collect some samples and take in the view. Yep, the atmosphere is mostly carbon dioxide with traces of nitrogen. That checks out. Okay, well, let's see if you can land here. This looks like the spot.
Mission Control, am I clear for landing? Mission Control? Looks like there's no signal. Initiating the landing sequence without clearance. Fingers crossed.
Landing your spacecraft would kick up clouds of dust that would take several minutes to settle down in the soupy atmosphere. As it clears, you'd look up into the sky, but you wouldn't find the familiar yellow circle of the sun. On Venus, it always looks like dawn, no matter what time of day it is. That's because the Venusian atmosphere only lets about 10% of the sunlight that hits it reach the surface. But wait, what were we saying earlier about the space probe that landed on Venus? Oh yeah, Venera 13. This Soviet probe made its fatal landing back in 1981. It survived the descent and lasted for a whopping 127 minutes. That's longer than any other spacecraft that had made it to the surface. But then, Venera 13 gave way to the violent, uninviting environment of this hell. It was likely crushed under extreme pressure. Or it melted. But it's too late to turn around now. You've lived through the 1-hour-long landing, and you're so close. All you need to do to complete your mission is to spend 5 seconds out there. Out there. In the most extreme environment you've ever been to. You made it! Whoa, the atmosphere is so strange. You can hardly lift your arms. Even though Venus has about the same gravity as Earth, you'd be feeling the sheer weight of its immensely dense air. It would feel like you were walking through water. Very hot water. And you'd be glad you were wearing so much protective gear. A quick look at your thermometer would tell you that it's a sweltering 475 degrees Celsius out here. That's hot enough to melt lead. Your pressurized suit would be working hard to keep you safe. Without it, you'd be crushed under all that pressure before you could even complete your mission. This isn't so bad after all. Hey, if a spacecraft could last over 2 hours, some 40 years ago, well, you and your shiny new gear can survive longer, right? Venus is right here for you to discover. Just take a few more steps. Suddenly, something distracts you from the first-hand human analysis of Venus's surface conditions. Your protective suit breaks. The drastic pressure shift would immediately make you feel like you were deep underwater. With an atmospheric pressure 90 times that of Earth, Venus would be crushing you from all directions. At the same time, you'd be struggling to breathe in an atmosphere without any oxygen. Any atmosphere you did manage to inhale would scald the inside of your mouth and the top of your throat. Unless you could scramble very quickly back to the safety of your spacecraft, you'd be dead within seconds. Hey, it could be worse. High above you, sulfuric acid clouds would be raining acid. But in this unbearably hot environment, the toxic rain wouldn't reach the surface. It would evaporate long before that. So at least you wouldn't have to worry about acid dissolving your skin and bones. That would be kind of gruesome. You know, in hindsight, maybe we shouldn't have sent you down to explore this hellish surface. We probably should have terraformed Venus into a more hospitable planet first.
The Earth might not be here forever. A huge solar flare, an asteroid impact, or a local gamma ray burst, anything could wipe us out for good. If we're looking for someplace to escape to, there is one planet in our solar system that's somewhat similar to Earth, though we don't know much about it. No, it's not Mars, it's Venus. Not only are Earth and Venus about the same size, they both have identical interiors with partially liquid cores, mantles, and crusts. Yet Venus happens to be the most hostile terrestrial planet in the solar system. But what if I told you that you could explore this hot planet without ever setting foot on it? This is What If. And here's what would happen if we built cloud cities on Venus. Venus isn't a place you'd want to land on. Thanks to its dense atmosphere and turtle-like rotation, the surface temperature of Venus stays at 462 degrees. The planet's atmospheric pressure is 92 times greater than Earth's. Because of such high pressure, anything entering the atmosphere of Venus gets immediately crushed before it reaches the planet's volcanic surface. With such extreme atmospheric conditions, it's too dangerous to attempt a manned landing on Venus, but we wouldn't need to go down there. Above the dense layer of clouds, Venus isn't that bad. The atmospheric pressure is similar to Earth's. The gravity is slightly lower, and the temperature reaches 75 degrees. Although that's a little hot, it's still workable. Now, how would we get there? Well, we'd need to start small. According to NASA's plan for exploring Venus, we'd send 2 spaceships to our destination. Venus is the closest planet to Earth. That's why it would only take 100 days for the craft to arrive there. One of the ships would be run by robots. It would carry a special airship that would eject into the atmosphere upon arrival. This airship would start to inflate itself with helium. And since helium is lighter than air, the airship would float, orbiting about 52 kilometers above the planet. The second spaceship would have a crew of 2 people. It would link up with the airship orbiting Venus. The crew would have 30 days to make all the environmental assessments. After that, they'd detach from the airship and start making their way back to Earth. The return trip would take about 300 days due to the Sun's strong gravitational pull. But even with that, the complete mission wouldn't take longer than 450 days. After analyzing the information from the first mission, we'd begin to plan our next trip to Venus. But this time, we'd stay there longer. The next crew would have a year to study the planet and its atmosphere. One of the things they'd be looking for on Venus would be life. Scientists think that because microbes on Earth can thrive in acidic conditions surrounded by sulfur, there could be life found in the Venusian atmosphere. After the end of the second mission, we would start preparing to stay on Venus permanently. We would begin building cloud cities, where future generations of humans would live and hopefully continue to explore space and the origins of life in it. They might even solve the pressure problem. From there, they would terraform the planet and settle down on the once hostile Venusian surface. Is alien life really out there? Humanity has wondered about it for decades. And according to scientists, it might finally be a reality. Astronomers have discovered there could be life on Venus. Does this mean we finally meet aliens? Could this help us discover other aliens? And what does this discovery mean for us? This is What If, and here's what would happen if there's life on Venus. Venus might not be as alien as you think. The planet is roughly the same size as Earth, and its gravity is 91% of our planet's. We always talk about Mars being a potential home for humans, but we shouldn't count out Venus either. And if there is life on the planet, could this speed up our process of making it our new home? First, let's look into why exactly scientists think there might be life on Venus. It all has to do with phosphine. This is a colorless, flammable, and explosive gas that's also pretty stinky. It smells like a mix of garlic and decaying fish. Ugh. This gas can be found on Earth, and it's dangerous to everything that uses oxygen to survive. It was used as a chemical weapon during World War I and is a byproduct of cooking methamphetamine. Yeah, this gas is not very pleasant, and it can be extremely deadly, but now astronomers have found that phosphine might be in Venus's atmosphere. At first glance, this might seem like a terrible thing because this gas kills anything that breathes oxygen. But that doesn't mean that life can't exist. Just because something doesn't require oxygen doesn't mean it's completely lifeless. Inside Venus's clouds of phosphine, there could be anaerobic bacteria. These are organisms that don't require oxygen to survive. They could be living on Venus, producing this phosphine gas. Keep in mind that all of this is not fully verified yet, but astronomers have been keeping an eye on Venus for nearly all of 2020, and this is what they think they've discovered. So, if this type of alien life really did exist on Venus, what would it mean for us humans? Well, when you first hear about alien life, you probably think about Martians with big heads and us being able to shake their hands, but that wouldn't be possible with these life forms on Venus. As it stands right now, we wouldn't be able to see any of the life on Venus with our naked eye. It's all bacteria and microbes. And with all that potential phosphine on the planet, it makes visiting Venus more dangerous for humans than ever. So, will we be meeting this life form anytime soon? Probably not. Is this discovery still incredibly exciting? Absolutely. And sure, it's discouraging that we haven't found Martians yet, but try not to be too disappointed. When discovering potential alien life, we should remember to expand our ideas about what exactly these alien life forms could be. They don't necessarily have to be something with 2 or 4 legs that humans are able to interact with. The possibilities for potential alien life are endless. Things we can't even imagine yet. And who knows what this current life form could turn into? It may start small, but in millions of years, we might see Venus bloom into a planet full of organic life. And life on Venus might not be limited to organisms living in phosphine gas either. Experts think that due to all the extreme climates on the planet, life could form almost anywhere. And that goes for the rest of the solar system too. With scientists discovering potential life on Venus, who knows what else is out there? Researchers will just have to keep searching to find out.
When it comes to planets in our solar system's habitable zone, one world is too close to the Sun, another is too far, and Earth is just right. But maybe things would be different if Venus and Mars simply swapped orbits. What makes these planets impossible to live on right now? What changes would they undergo when they traded places? And why would you need Jupiter to give these planets a chance at supporting life? This is What If, and here's what would happen if Venus and Mars swapped orbits. Our solar system's habitable zone, otherwise known as the Goldilocks zone, is the distance from a star where liquid water could exist on the surface of a planet. As long as conditions aren't too hot or too cold, life could be possible, just like on Earth. But simply occupying prime real estate in the habitable zone isn't a guarantee that a rocky planet is actually habitable. Both Venus and Mars orbit within this region too, and yet no life. Despite being of a similar size and with roughly the same surface gravity as Earth, Venus is too hot to hold liquid water. And dense. Its atmosphere is 90 times denser than our own, and the surface temperature is a scorching 462 degrees Celsius. On the other end of the Goldilocks zone, Mars is also quite Earth-like, except way colder, drier, and dustier. Its average surface temperature is minus 46 degrees Celsius, and it has an atmosphere about 1% as thick as Earth's. So if we swapped things around, would Venus and Mars transform themselves into perfectly livable planets? Bringing the red planet into Venus's orbit would put it at a distance of approximately 108 million kilometers from the Sun. This would bring it halfway closer to the Sun than it was before. Being so much closer, Mars would get a significant boost in the amount of sunlight it receives, and that alone can make the surface temperature climb to a balmy 32 degrees Celsius, just like the Earth's tropics. But without a thick atmosphere or oceans, all this new heat wouldn't stay on the planet. Just like in Earth's deserts, Mars would see extreme temperature differences between day and night. The thin Martian atmosphere would make it difficult for water to stay liquid. With such a low surface pressure, water would boil at a lower temperature. Evaporation would happen much quicker. Looks like if you want to see life flourish on Mars, you'd have to take a slightly more hands-on approach. But first, let's check out how Venus is doing in its new neck of the woods. You'd now find Venus located 228 million kilometers away from the Sun. That's twice as far as it used to be. And naturally, you'd think, surely this scorching planet would be starting to cool down. Well, as it turns out, the planet's high surface temperatures have a lot more to do with its thick atmosphere than its overall closeness to the Sun. Venus has a very high albedo, which means that it reflects about 75% of the incoming sunlight. So it could be that the planet's temperature remains more or less just as hot as before. Even as the upper parts of the atmosphere slowly cool enough for the albedo effect to decrease, that would mean that Venus could now absorb a larger amount of incoming sunlight, so that temperature wouldn't start to drop all that much. Another setback on the road to becoming a life-supporting planet would be that Venus's atmosphere is mostly comprised of carbon dioxide, with small amounts of nitrogen and clouds of sulfuric acid. What you still wouldn't find nearly enough of is water. The concentration of water in Venus's atmosphere is 100 times too low for even the most resilient organisms back on Earth to survive. But since you went through all the effort of bringing both planets from one end of the habitable zone to the other, why not take things a little further? You could try terraforming the planets to make them a little more livable. One way you could increase the surface pressure of Mars would be to try releasing all the carbon dioxide found in its soil and minerals. The only problem here is that the red planet would need to reach temperatures above 300 degrees Celsius. And despite this new location so close to the Sun, Mars wouldn't ever get this hot. Besides, if you could release all of that precious greenhouse gas, it would only amount to an atmospheric pressure of about 10 to 14% of Earth's. There simply isn't enough carbon dioxide on the red planet. Even if you had been successful with that effort, you'd still be unable to breathe on Mars. One option for dealing with this would involve bringing special microorganisms to the planet that could convert the hostile Martian atmosphere into breathable air. This would be similar to what Earth was like 2.5 billion years ago. Back then, cyanobacteria converted our methane and ammonia-rich atmosphere into the oxygen-rich one you enjoy today. But ultimately, this would be a big waste of time and resources. You'd find that with Mars's weak magnetic field, it wouldn't be able to hold on to any atmosphere you could create. That would be thanks to the power of solar winds that would constantly strip away whatever atmosphere you'd managed to generate. And sitting in Venus's old orbit, solar winds would be almost 5 times as dense as Mars is used to. Way out on Venus, the question of creating conditions for life could come down to whether you could manage to form an ocean on the planet. And that would entail bombarding the atmosphere with hydrogen. As hydrogen is introduced to the atmosphere, it would react with the carbon dioxide, leading to the formation of water. Introduce enough hydrogen and you could eventually see Venus with 80% of its surface covered in water. For this to work, you'd need a lot of hydrogen. So much that you'd probably need to find a way to harvest it from a gas giant like Jupiter or Saturn, or maybe one of their moons. Yeah, I'm not sure all this planet moving and hydrogen bombarding was really worth it. You'd still be left with only one Goldilocks planet capable of supporting life. But what if all the planets were in the habitable zone?
When I say jump, you say how high. Okay, let's put this to the ultimate test by hopping around the solar system. Literally. What differences in gravity would you experience? On which planet could you jump as high as a house? And on which planets would jumping lead to your demise? This is What If. And here's what would happen if you jumped on every planet in the solar system.
Every object with mass is subject to gravity. This includes you, of course. Whether you're standing on your 2 feet or lounging on the sofa, the Earth's gravity is pulling you toward the center of the planet. When you jump, the force of your muscles allows you to overcome that gravity and accelerate upward. Once you're in the air, gravity slows you down, and eventually your velocity hits zero and you fall back to the surface. The planets in our solar system come in all sizes, so the force of their gravity differs too. Your mass would stay exactly the same, but from one planet to the next, your weight would be very different.
You guys lost a pound.
So, could you bound gracefully over mountains on one while on another you'd barely be able to lift a toe? Your interplanetary jumping experiment would begin right here on Earth. Okay, not the most exciting place to start, but a good place of comparison. If you're close to the average jumper, you should be able to squat, swing your arms, and leap about half a meter high, all in about 1 second. But don't let me underestimate you. If you're an extremely talented athlete, like Javier Sotomayor, you could set a new world record by jumping over 2.45 meters. Whoa, not too shabby. Making a quick first stop on the moon, you'd find gravity 6 times weaker than it is on Earth. Well, that's because the moon has about 80 times less mass. Here, you'd only need to jump at a velocity of 2 kilometers per second to lift off the surface. And with your average jumping velocity, you should be able to jump about 3 meters high. Meanwhile, Earth's most talented jumper would be able to bound over an entire house. Okay, moving on to the rocky surface of the planet closest to the Sun, Mercury. With a spectacular close-up view and temperatures hitting 430 degrees, you'd be drenched in sweat already. Mercury is smaller than Earth. The gravitational pull is about 1/3 of what you're accustomed to here at home. So, despite exhausting conditions, you'd be able to jump about 3 times as high. Okay, let's get out of the frying pan and into the fire by taking a leap on an even hotter planet, Venus. Very similar in size to Earth, this planet has a surface gravity about 91% of Earth's. Here, you'd be able to jump ever so slightly higher than you could back home. But you definitely wouldn't want to hang out for too long in this thick, scorching hot atmosphere. So, time to cool off on Mars. You better keep your leg muscles warm though. The average temperature on the red planet is minus 62 degrees. But the good news, you'd feel lighter. Mars has about 10 times less mass than Earth, and for this reason, you'd be able to jump to nearly the exact same height as you did back on Mercury. Okay, now leaving the rocky planets behind, it would be time to test your skills on a gas giant, like Jupiter. This planet is so large that all the other planets of the solar system could fit inside it. Jupiter has very intense gravity, so you'd be feeling a lot heavier than you do right now. If you tried to jump here, you'd only be able to get a pathetic 20 centimeters off the ground. Now, if it helps your ego, this scenario would be impossible for a simple reason. It's because the gas giants have no surface to jump from, so you'd have to stay on top of your spaceship. And if I can offer some advice, don't fall off. On Saturn, you'd be surprised to find that you can jump only about 3 centimeters less than you could on Earth. Despite the planet having 95 times the mass, Saturn's surface gravity is quite similar to our home planet. Okay, now heading toward the dark, cold edges of the solar system, you'd take your leaps on Uranus and Neptune. Just be sure to avoid slipping on these ice giants. On Uranus, you'd find a relatively familiar gravitational pull. Because of this, you'd be able to jump about 6 centimeters higher than you could on Earth. Then finally, you'd reach the bleak, foggy surface of Neptune, and despite your aching muscles, you'd power through for one last jump. And that could be tough, considering the severe winds that dwarf even the largest hurricanes back on Earth. But you'd take your best shot, and struggling against the slightly stronger gravity, you'd reach 44 centimeters, roughly the same as back home. Speaking of back home, I think it's time to head back. Okay, you'd make it home exhausted.
What happened?
Too bad all the planets weren't closer together, like stuffed into the habitable zone. Some of the planets in our solar system are gigantic, but what if they got even bigger? Let's go up the planetary size chart and see what kind of chaos doubling the size of every planet would make. What would it be like to live on a super Earth? How big would Jupiter need to get to become a star? And would Pluto finally regain its planetary status? This is What If, and here's what would happen if all the planets doubled in size. Doubling the radius of every planet in the solar system would make each of them 8 times more massive, but you wouldn't need to worry about our solar system's great ball of fire getting bigger and hotter. For the sake of this experiment, let's keep the sun the same size it already is. But could the gravitational pull of a super Jupiter kickstart a chain of events that would result in the destruction of the solar system? Mercury. At its current size, the rocky planet closest to the sun is only slightly larger than our moon. Doubling it in size would make it nearly half as massive as Earth. And despite the fact that Mercury stopped being volcanically active 3.5 billion years ago, expanding its interior would mean all that internal energy would need to escape somewhere. So there could be some more explosive volcanic eruptions in Mercury's future. Venus. Venus is very similar in size to Earth, but one of its many differences is that its atmosphere is so thick that the surface pressure is 95 times stronger than our own. Venus's increased gravity would pull the atmosphere even closer to its surface. This could result in the atmosphere becoming so dense that walking through it would feel more like walking through water. Except you'd really be walking through incredibly thick carbon dioxide. Earth. If Earth expanded to twice its size, the first big change you'd notice is that you'd feel a lot heavier. Within seconds, you'd go from your 75 kilogram weight to feeling like you were 150 kilograms. That would be because the force of gravity pulling on you would be twice as strong. You better hit the gym to strengthen up fast because this wouldn't be easy on your body. Your heart would need to work twice as hard to pump blood around, and pressure would build up on your joints. Jumping, flying, or sending rockets into space could become a thing of the past. You'd need much more fuel, power, and money to leave Earth's surface and travel through its even thicker atmosphere. Mars. Now, if the red planet ballooned to twice its size, there's a chance you would barely recognize it. What was once a dry, desolate place could eventually transform into a more Earth-like planet with oceans, rivers, and a thick atmosphere. Mars lost its magnetic field and then its atmosphere, likely because of chemical changes inside its core. But if the Martian core got bigger and hotter, it could restart the magnetic field. And that, in turn, would protect Mars from solar winds and give it a chance at kickstarting life. Jupiter. Doubled in size, Jupiter would continue to be an intimidatingly huge planet. It would stay 318 times larger than Earth and 2.5 times more massive than all the other planets combined. And the impact of this would be so huge that it would likely shift the actual center of our solar system. You see, the planets in our solar system don't exactly revolve around the sun. No, they orbit the common center of mass, or barycenter. And thanks to Jupiter's normal size, this barycenter is actually 48,000 kilometers away from the center of the sun. But doubled up, this point in space would move even further away from the sun. You'd see material from the asteroid belt being pulled toward Jupiter or further out into the solar system. But even this big, Jupiter wouldn't be massive enough to become a full-blown star. To do that, it would need to increase to 85 times its current mass. Though it wouldn't be far off from star status. At 13 times its original mass, Jupiter could become a brown dwarf star. Saturn. With a bigger Saturn, you could kiss its beautiful rings goodbye. The monumental increase in the planet's surface gravity would upset the balance of the ring materials, as well as Saturn's 5 small moons. They'd start falling towards its surface at a higher rate. Saturn is already slowly losing its rings. Every 30 minutes, material containing enough water to fill an Olympic-sized swimming pool falls down to the planet. Uranus. Now, beyond its added heft, not all that much would change for the ice giant Uranus way out on the edges of the solar system. It would continue holding the record for the stinkiest planet. If doubling Uranus's size would mean doubling the amount of hydrogen sulfide in its upper atmosphere, this stinker might spread an even stronger stench of rotten eggs. Ugh, I wouldn't want to go near this planet. Neptune. Neptune's fate wouldn't be too different from its giant frozen neighbor. Except Neptune's increased gravitational pull could eventually lead to the disappearance of some or all of the billions of icy objects located outside its orbit. Neptune has already swallowed the equivalent of 7 to 10 times the mass of Earth in material from the Kuiper Belt. Pluto. If Pluto doubled in size, well, it could be back on track to regain its official status as a planet. If its added mass and gravity could manage to pull away debris from its surrounding neighborhood, it might just be able to rejoin the rest of the family. Alright, so it's safe to say that all the planets doubling in size wouldn't exactly bring about a cataclysmic end of the solar system. It would, however, cause a little chaos. Our solar system has 8 planets, a few dwarf planets, and more than 200 moons. But wait, are you seeing double? Or did every planet suddenly get a twin? Where would each planet's double fit in? Why would Earth 2.0 not support any life? And which planet's twin could turn out to be habitable? This is What If, and here's what would happen if every planet had a twin. The solar system has 3 types of planets: rocky, gaseous, and icy. These all formed after our sun was born from a spinning disk of dust and gas. As temperatures in the solar system rose, the inner regions were as hot as 1730 degrees Celsius. And only substances with very high melting points like iron, silicon, and magnesium could remain solid. This gave way to our rocky terrestrial planets, Mercury, Venus, Earth, and Mars. Further out, temperatures were as cool as minus 225 degrees Celsius. So the outer planets like Jupiter and Saturn attracted massive amounts of hydrogen and helium. Then beyond that, Uranus and Neptune formed out of methane and water. All these planets formed in the exact right location with the perfect conditions for what they are today, especially Earth. But on What If, since everything is possible, not only will we double every planet in the solar system, but we're also going to line these planetary twins up in reverse order. What could go wrong? I know. Pluto isn't a planet anymore. It was demoted to a dwarf planet back in 2006. But for the sake of this scenario, Pluto will make a comeback. Only this time, instead of being formed on the outskirts of the solar system, it would orbit dangerously close to the Sun. The original Pluto is about 2/3 the size of our moon, but Pluto's twin would be much smaller. Being so close to the Sun, its mantle of water ice would boil away, leaving behind only a small rocky core. Next up, you'd find Mercury in its usual first position from the Sun, but except this time, on the exact opposite side of its orbital path, it would be joined by the twin version of the ice giant Neptune. Now, looking at Neptune's twin, you'd barely recognize it. The Sun would rip gases out of its atmosphere and pull them toward the star itself. Yeah, looks like putting an ice giant right next to the Sun is a very bad idea. What were you thinking? Eventually, Neptune could be in danger of losing its entire atmosphere. Now, you certainly wouldn't see this happen overnight. Maybe if you set up the world's most epic time-lapse, you could see this unfold over the next 10 million years. Venus is often referred to as the planet of love, which would now be extra exciting because you could watch it circle the Sun with a new dance partner, Uranus's twin. This partnership would be a relatively harmonious one for both of them, and neither would see much of a change, but I need to warn you, Earth's planetary neighborhood could get stinky. All thanks to Uranus's atmosphere that carries the whiff of farts anywhere it goes. Now, Uranus's twin would be a great place for a quick visit, especially if you were looking to get rich. You might get caught in one of its diamond rainstorms and collect some bling that's been formed in the atmosphere's immensely high-pressured environment. Just don't forget your spacesuit. Next up, the Earth's orbit. You'd get to look into the night sky from wherever you are and see the spectacle that is the twin of Saturn. And you'd be in for a treat. A magnificent view of the planet's swirling yellow storm clouds. Not to mention at least 62 moons shining down on you. But just because it would be joining us in the habitable zone doesn't mean this gas giant would be able to support life. Saturn's twin still wouldn't have a solid surface, and super fast winds would whip around the planet's upper atmosphere at speeds of up to 1,800 kilometers per hour. The problem is that while you're enjoying the spectacle, this twin's gravity would start tearing our planet apart, and its moons might be set on a collision course with us. odds are that this planetary configuration would wipe out all life on Earth. Okay, enough of the bad stuff. Let's talk about Mars. The red planet would be paired with the world that is home to the infamous Great Red Spot. Yeah, you guessed it. The twin of Jupiter is about to crash this party. The copy of the largest planet in the solar system would be located at the very edge of the Sun's habitable zone. Now, that wouldn't mean that Jupiter's twin could support life. It would still be made of gas with no solid surface, but its presence so close to Mars could cause Mars to turn into a lush, habitable world. Mars is a dry desert with no liquid water and hardly any atmosphere. Well, that's largely thanks to the disappearance of its magnetic field, which used to hold its atmosphere together. This likely happened when Mars got bombarded by asteroids in its early days. But if Jupiter's twin and its strong gravitational force were around back then, well, it could have saved Mars from those asteroid collisions. Then Mars could have kept its atmosphere, and maybe there'd be life there today. Or maybe this twin of the largest planet in the solar system would have sent even more asteroids toward Mars. Maybe even right toward Earth, meaning life probably wouldn't even have the chance to form. Okay, on the opposite side of our solar system's asteroid belt, you'd find all these pairings repeated. Starting with the original Jupiter and the twin of Mars. Things would stay pretty much the same. Jupiter would still be big and gaseous, while Mars would be cold, dry, and lifeless. And then there would be Earth 2.0. Now sharing an orbit with Saturn, you'd find Earth's twin way outside the Sun's habitable zone. Here, you'd receive 1% as much sunlight as you get back home. From space, Earth 2.0 would look like a frozen snowball version of our planet. The oceans would mostly freeze over, but that wouldn't mean that pockets of life couldn't still exist under all that ice. Deep in the ocean, close to hydrothermal vents, there could be enough heat to sustain life. The tidal motion of the water could move that geothermal heat around, allowing parts of it to remain liquid. Next on the list, the twin of Venus, located right next to Uranus and 27 times further away from the Sun than it is now. This would cause its temperatures to drop. The original Venus is known for its scorching hot surface temperatures that can be as high as 475 degrees Celsius. Even this far from the Sun, the Venusian twin could still retain some of its warmth. But you wouldn't be able to move there just yet. Its thick atmosphere would be full of lethal amounts of carbon dioxide and sulfuric acid, so you'd have to terraform it first. Finally, reaching the outer edge of the solar system, you'd find Mercury's twin circling the Sun in the same orbit as Neptune. While the original Mercury is the second hottest planet, this world would be a frozen rock. It would also look eerily similar to our moon. Okay, that's the end of our journey through this crowded version of the solar system, but I wonder what things would look like if it was all a little closer together. Whoa! Our solar system is plunging into chaos. Better hang on tight, the planets are getting knocked out of orbit. What could kickstart this epic chain of events? How would this impact each and every planet? And how could it possibly make Earth even more hospitable to life? This is What If, and here's what would happen if the planets were knocked off course. The solar system's planets have remained in stable orbit around the Sun for billions of years. And they'll likely remain so for at least another 100,000 years. Thanks, Newton's first law of motion. But the forces that disturb this balance could already be underway. Like a giant rogue star not bound to any galaxy, or a wandering black hole. And bad news for us, our universe is littered with agents of chaos, ready to disrupt our planetary neighborhood at any moment. It would all start with Neptune. Neptune doesn't need to be knocked out of alignment much for bad things to happen. If this icy giant's orbit changed by even 0.1%, it could trigger a series of events that really mess things up. With Neptune's orbit in flux, it would begin to influence the orbits of its neighbors, and sooner or later, each planet's disturbed orbit would unleash total chaos in our solar system. At first, you wouldn't see much from Earth. Only astronomers would notice the slightest changes in planetary orbits. They'd be the first to know that something really wrong was about to happen. These disturbances would build up and eventually they'd reach a tipping point. Neptune's changed orbit would affect Uranus. These two ice giants would come dangerously close to each other. And then they'd pluck Saturn out of its orbit. This trio could be ejected out of the solar system entirely, and none of the other planets would be safe from this ensuing cosmic pandemonium. Because as Neptune, Uranus, and Saturn were on the way out of our planetary neighborhood, they'd shove the biggest planet in the solar system off its rails, Jupiter. Instead of revolving around the Sun in an almost perfect circle, Jupiter would now have an erratic elliptical orbit. Sometimes it would be closer, and other times it would be further away. And this would impact Earth's orbit as well. One peculiar effect would be a new kind of global warming. Our new orbit would result in the coldest parts of the planet reaching more pleasant temperatures. As this celestial domino effect continued, Venus's orbit would change too. If it started to spend more time further away from the Sun, would there be a chance that it could cool down enough to become habitable? Well, not exactly. Venus's scorching temperatures run as high as 462 degrees Celsius. And that's not just because of its proximity to the Sun. It's due to its runaway greenhouse effect. Venus's thick atmosphere already reflects about 75% of any incoming radiation. A relatively small shift in its position wouldn't be enough to offset the greenhouse gases that keep it sweltering. On the other hand, Mercury wouldn't be let off the hook so easily. A new orbit could lead to a close encounter with the Sun, and that could eject it from the solar system as well. All these planets being forced into new trajectories could also lead to something a little more dramatic than just close encounters. They could collide. Yeah, Venus and Mercury could slam into each other and form a new planet. Well, brace yourself for the possibility of a full-on collision with Mars. If that happened, it would be bad news for you. If Mars crashed into Earth, well, there would be no way you'd survive this impact. And you'd have nowhere to run from this doomsday scenario. Now, should you be worried about any of this? Well, most flybys close to our solar system, like a rogue star, probably wouldn't lead to such a dramatic destabilization. Anything we might consider to be a threat only occurs once every 100 billion years. Body-crushing pressure, toxic atmospheres, unbearable temperatures. That's what would be in store for you if you visited other planets in our solar system. But what other environmental hazards would you encounter? Which planets would be the safest and which would be the most dangerous? And how long could you survive on any of them? This is What If, and here's what would happen if you spent a day on every planet in our solar system. Before you get started on your journey through the solar system, you should pack a bottle of water. Earth is the only planet known to have consistent bodies of liquid water on its surface, so if you pack enough, you could probably survive a few days just about anywhere, right? Well, sorry to say, I've got some bad news for you. Let's start with a visit to Mercury, the smallest planet in the solar system. This rocky, crater-filled planet is only slightly larger than our moon, and it's located extremely close to the sun at a distance of 58 million kilometers. Now, even though a day on Mercury equals about 59 days on Earth, your trip wouldn't last anywhere near that long. Due to this slow rotation, you could land on the sunny half where the temperatures reach 430 degrees Celsius, or maybe you'd aim for the dark side where temperatures drop to minus 180 degrees Celsius. Your best bet would be to find a cozy spot somewhere in between. But with an atmosphere mainly composed of oxygen, sodium, hydrogen, helium, and potassium, good luck breathing for very long. Even in this middle ground, you wouldn't likely survive more than 2 minutes. Okay, let's check out what a day would be like on the second planet from the Sun, Venus. Well, you should expect a very warm welcome because surface temperatures are a piping hot 475 degrees Celsius. And one day on Venus lasts 243 Earth days. Unless you've got an impossibly robust spacecraft, you couldn't get very close to the surface. And even if you did, you wouldn't last very long. Venus has a thick and toxic atmosphere with 154,000 times more carbon than the atmosphere of Earth. And it's shrouded in yellowish clouds of sulfuric acid. You could say the Venusian atmosphere is a runaway greenhouse effect. Between the toxicity and the heat burning you to a crisp, you wouldn't survive 1 second on Venus. Now, let's skip on over to Mars. Unless you wanted to stop back on Earth for a couple breaths of fresh air. On Mars, you'd find comfort in a day that is a little over 24 hours. What you wouldn't find comfortable is an atmosphere of carbon dioxide, argon, nitrogen, and a little bit of oxygen and water vapor. The surface of Mars is cold, with an average temperature of minus 62 degrees Celsius. Combine the low surface temperatures with the unbreathable air, and you wouldn't survive much more than a few minutes here either. On the next planet, you wouldn't be able to reach the surface. That's because there isn't one on the gas giant Jupiter. This planet is more than twice as massive as all the other planets in our solar system combined. And its atmosphere is primarily hydrogen, helium, and cold, windy clouds of ammonia and water. Jupiter might be bulky, but it rotates fast. One day lasts a mere 10 Earth hours. And because it's so fast, Jupiter's atmosphere has strong jet streams. Plus, the Great Red Spot that is actually a storm, bigger than the size of Earth. If you fell into the planet, you would enter the atmosphere at a whopping 49 kilometers per second. And as you kept falling, the atmosphere would become denser and more turbulent. You might feel like you were slamming into a wall again and again. If you made it 692 kilometers down, you would find pressure levels higher than at the bottom of the Mariana Trench, the deepest place on Earth. If the pressure didn't kill you, the temperature, which averages minus 145 degrees Celsius, certainly would. You wouldn't survive on Jupiter for 1 second.
Wow.
Now, if you continued on to Saturn, you'd find another gaseous giant without a surface, and like Jupiter, a day lasts about 10.7 hours. Here, you would experience deadly strong winds, reaching up to 1,800 kilometers per hour. With an unbreathable atmosphere made of hydrogen and helium, Saturn is incapable of supporting life. Maybe you'd have more luck on one of its moons, like Titan or Enceladus. These two moons have internal oceans, which could theoretically support life. Okay, moving on to the first of the ice giants in our solar system, Uranus. No surprise here that it also has an unbreathable atmosphere of hydrogen, helium, and methane, which gives the planet its signature blue-green color and the stink of rotten eggs. There are some other unusual hazards on Uranus you'd need to be prepared for, such as mysterious flares of X-rays and lethal diamond rain. Yeah, you heard that right. Highly compressed diamonds of carbon atoms raining down from the atmosphere. But don't worry about that. The immense pressure on this planet would kill you in less than a second. Alright, last but not least, Neptune. A dark, cold planet with supersonic winds as strong as 2,000 kilometers per hour. That's faster than the top speed of a fighter jet. So if the pressure didn't kill you, those supersonic winds would probably do the trick. A day on Neptune would last for 16 Earth hours, but your life there wouldn't last a second. Okay, there it is. So in case it isn't clear, Earth would be the only planet you would want to visit anytime soon. Just about anywhere else, you could look forward to a deadly cocktail of high pressure and toxic gas. I mean, that is, unless we terraformed Mars, creating a second home for humanity within the solar system. But that's a story for another What If.